Welcome to the first video tutorial of Open Commissioning. In this video, we will show you how to set up and get started with the Open Commissioning Unity package and walk through some samples of the package. If you're unfamiliar with the concepts of Open Commissioning, you can head over to the GitHub repository where there are documentations to get you started. So let's start with a completely empty Unity project in the version 2022.3. And we begin by installing the dependency packages of Open Commissioning, which are Unitask and Naughty attributes. So let's head over to the repository of the Unity package. We can see here the dependency. Okay, now the two packages are installed, and we can continue by installing the Open Commissioning package itself. To install the Open Commissioning Unity package, you can head over to the repository of the package, switch to the UPM branch of the version you want to install, then copy the URL, go back to Unity, open again the package manager, and add package from the Git URL, just paste it in there, and it will install. So after the Open Commissioning package is installed, we have to set two settings to ensure that everything is working correctly. The first one is to create the default layers and their collision matrix. We can do that by clicking on Open Commissioning in the menu, go to Settings and apply default layers. You get a message that the layers are created and the collision matrix is set. You can also see here in layers, there are new layers created, interactions, transport, stopper, and reader, which are required for Open Commissioning. The second setting is to allow the Unity player to run in background. This ensures that the simulation is still running when we are active in other programs, such as TwinCAT, for example. So we go to Edit and Project Settings, go to the Player tab, open the Resolution and Presentation section, and check the Run in Background option. So let's import the samples using the package manager. In the package under the Samples tab, you can click Import, which then imports the samples into your Assets folder. And we can see the demo folder we have, the component scene, which we open now. So in the demo scene, there is an example project which contains some basic components of Open Commissioning and is good to get an overview of the functionality of the components, how they work together, and the structure of the project, etc. In this video, we won't go into how to model different components and devices from scratch. This is about giving a first impression with an already modeled project. Also, as you can see, the geometry of the examples here is kept very simple. Of course, you can use real CAD data, then this will become more complex. This is just for demonstration purposes. So in this case, this is enough. So when we look inside the hierarchy of this sample scene, we see the project containing all the example devices. So in this case, we have some cylinders, some drives, some binary sensors and analog sensors, and some basic interactions. So let's have a look at the different devices, the components that model them, and how we can control them manually during the simulation. At the moment the simulation is not running, we have to start it by entering play mode in Unity. So the simulation is started. We can clearly see something is moving, so it is running. We have a little message that the ADS client is stopped. This makes sense because at the moment there's no TwinCAT system running, so we can acknowledge that and clear the console to hide the message. Okay, let's begin by having a look at the cylinders. So I select it and press F so they can focus. So when we look inside this group, we can see that there are 3 cylinder objects. All of them have the cylinder component of open commissioning attached to them, which is used to model a cylinder movement. So let's have a look at the first one. Bring that in focus again, zoom a little bit outside, and go over to the inspector view of that component. So to manually control it, we have to activate the override option here. After that, we can see that 2 buttons became available, plus and minus. The plus button, of course, when I press it, the cylinder extends. And when I press the minus button, it will retract again. We can also see the status visualization in the progress bar and the current value, which is the position of the cylinder in millimeters. The second and third cylinder also have the same cylinder component, but they are of different types. The first one was a double acting cylinder. The second one is a single acting positive one. That means if we press minus, it will retract, but if we stop pressing, it will jump back into the positive direction. The third one is a single acting negative, so it's the exact opposite. If we override it, we can extend it, and if we stop overriding it, it will retract automatically. The next devices we are looking at are the drives. So let's focus to them. We also have 3 examples: drive simple, drive speed, and drive position, which all have some kind of drive component attached to them. So let's look at the first one, the drive simple. The drive simple component has 2 control signals, forward and backward. When we override them and press one of them, we see that the axis of this drive accelerates to a specified value. In this case, it's 100 degrees per second. And if we press backward, it will accelerate in the opposite direction, also the same dimension. The next example is the drive speed device. This component takes target value and accelerates the axis to that value with a specified acceleration. So when we override it and specify a value here, for example, again, the dimensions are 100 degrees per second, it will rotate the axis with that speed. If we change it to, for example, 200, it will accelerate to that value. Also, if we specify a negative value, it will rotate in the opposite direction. The last example is the drive position component, which takes also one control value specifying the target position. So when we override it and specify a value, it will move to that position with the specified speed. The dimensions here are millimeters. Next, we will have a look at the binary sensors. So what we see here is a part that is automatically moving on this table here. And we have 3 binary sensors that can detect that part. And as soon as it's colliding with the detection zone, it outputs a value. So if we have a look in the inspector, we can also see that as soon as it's colliding with the part, it outputs a value. There's also a visual indication. So the line switches from green to red when there's a collision and a value is generated. And as soon as the part leaves the detection zone, of course, the value gets 0 again. The next group are the analog sensors. So let's have a look at them. We also have 3 examples for them here. So if we look at the first one, we see the sensor analog component attached to that game object. So the sensor analog component receives a value from a value source and then forwards that value to its behavior model running in TwinCAT. The value source can be different things. In this example, it's measuring the distance between the sensor and the moving part here. In the second example, there's also the sensor analog component, but the value source is the measurement angle component here, which measures the angle of rotation of that part here. And the third example also has the sensor analog component, and its value source is the measurement displacement force component, which calculates the displacement force based on the movement of that part here. So those examples already give an idea of the modular architecture of the different components in open commissioning. The sensor analog components task is to receive a value from value source and to forward that to TwinCAT, while the measurements device is responsible for generating and calculating a value that the analog sensor represents. So if we need to model another thing that is represented by an analog value, we only have to develop the measurement device for that. So we are more flexible and we don't need to develop as much. The last group of devices are the interactions, which are components that the user can interact with during the simulation. So here we have a button, a toggle button, a switch, and a lamp. So let's start with the button. It's quite simple. We have this field here inside the inspector window. If we press it, we see that the status is pressed and it's also getting a feedback. And we also see a little press animation in the 3D environment. This value gets sent to the behavior model running in TwinCAT. The toggle is similar. We can toggle this here, but it stays pressed. And if we toggle it again, it will release. The switch button has different positions. In this case, it has two with an angle of 45 degrees. So if we press it, it will switch to the next state. There's also a little animation inside the simulation. And if we press again, it will switch between the states. The last one is a lamp, which is also very simple. If we override it and give it a signal, it will turn on. And if we release the signal, it will turn off. So this brings us to the end of that short introduction to the open commissioning Unity package. Of course, there are more components in the package than we showed here in the demo scene. You can explore them by installing the package on your own system or have a look at the official documentation in the repository. Thank you very much.